Hello everybody, it is Caleb, and today I want to show you the revised K20 by GLP bar for Unreal Engine that I have made. I did refactor it by a bit, and it made a couple changes for the better. I did make a video of me making all these changes, but it ended up not going too well. I made a lot of miswires and little mistakes, and so instead of showing the whole video of me refactoring it into a DMX Actor blueprint parent class, I'm just going to give a walkthrough of the fixture. So I do want to give a big shout out to my Patreon supporters. Y'all have given me a lot of feedback lately about what direction I should go with building these fixtures and how I can build them, and things like using the MVR workflow that Eterno told me about. Kendrick Feller, I saw your note about LED strips, and so I'm currently working on an LED strip. Secret meeting, I haven't gotten to talk to you yet. Tong Huan, I am making this video for you because you wanted to see an explanation of the GLP X4 bar. And also how to migrate that asset into your project file. So I'm going to do all that today. Let's get started with exploring this blueprint. Now, the first thing I did is this parent class is now a DMX Fixture Actor matrix. And what that means is that it will now respond if I want to change these fixture addresses. So let's say I select all 8 of these and I remove their patch. So now none of them are patched. I could even patch all of them to, well, there's no library here, but I'm going to patch them all to a QPix, which doesn't make sense. And so what you can do now is select all 8 and then go to DMX Patch tool and just hit address incremental on the correct library with any number of fixtures patched. And now this will be X4 bar number 0, number 1, 2, 3, 4, 5, 6, 7. So I also believe that's in the order that you select them. So that was out of order there. So now if I hit address incremental, well, I should do it this way. 501, 502, 503, 504. That's correct. So yes, it addresses them in the order in which you select them. So let me go over some of the features of this fixture. The first is that, like I showed you, the beams do respond. Well, first off, the fixture responds to tilt. All of the pixels respond to the fixture's master dimmer channel. And then they can also zoom. So that's in a narrow. And if you look at these cells up close, especially if I hit hide beam mesh, well, I have to select it on all of them. As you narrow into 0, or as you go towards narrow, each cell gets bigger. And as you back out towards wide, each cell gets smaller. Now, unrealistically, it will show more than 1 pixel per cell, when realistically the cell would just get smaller. But I decided to save a bit of sanity and not try to address that, and figure that at least on the x-axis it looks close enough. As you can see, the rectangle light also changes depending on the zoom level. And all of these fixtures have the ability to hide the beam mesh or lower the haze amount And then if you do that, you usually need to like flash the Grandmaster or something to re-push those values out. It won't just change right away. So you can lower the haze amount to a much finer amount. You can also hide the light. And then you can also say do not color body. And it should black out. Yeah, so now it's not going to render all those cells. And if we uncheck it and flash our Grandmaster again, then it will. So those are all the attributes. So if you had like this bottom row per se hid behind some scenic or some drums, you could totally not color the body. In fact, it would be nice if eventually I made the option to completely just disable the body so the engine doesn't have to render it at all. I'm going to leave that out for now. I might come back to that and do a lap and hit those later. And so what you can do now is select all 8 and then go to DMX Patch Tool and just hit Address Incremental on the correct library with any number of fixtures patched. And now this will be X4 bar number 0, number 1, 2, 3, 4, 5, 6, 7. So I also believe that's in the order that you select them. So that was out of order there. So now if I hit Address Incremental, well, I should do it this way. 501, 502, 503, 504. That's correct. So yes, it addresses them in the order in which you select them. The other thing I did is refactor the materials blueprint, but let me first walk you through the actual blueprint. I'm going to start though by walking you guys through the viewport. So let's zoom in a bit. Well, I should do it this way. 501, 502, 503, 504. That's correct. So yes, it addresses them in the order in which you select them. The other thing I did is refactor the materials blueprint, but let me first walk you through the actual blueprint. I'm going to start though by walking you guys through the viewport. So let's zoom in a bit. So I think I am going to go over and kind of respace these because I do notice this gap here between the two beam meshes. So I'm going to hit that before I upload it. Well, what you need to know is that this base here is not deletable. It's part of the DMX Fixture Actor class. And then the base to the fixture is on this static mesh base. So I can rename this X4 base so that we know this was something added specifically to the X4 bar in here. Yoke is rendered completely useless. I have made it not visible and hidden in game, and then removed the static mesh component from it, wherever that was. Don't remember where that was. And then the head is kind of just a placeholder to hold all of these other things. The matrix head is disabled as well. If you have that on when you are trying to bring this fixture in, you're going to notice this procedurally generated box when you go into game mode, and that's the matrix head. And so I disabled this so you don't see it. The spotlight component here is part of the DMX Fixture Actor class, but I cannot figure out how to get rid of it. I can remove this initialized matrix fixture, which might need to be relinked, honestly, and I think I'm just going to do that because all it does is set the all it does is lock the attenuation radius in. Without it, you can go in your map, you can lower the attenuation radius of the spotlight through here by clicking on the component, but there's no way to do that in bulk. So that's why I disabled it there. But I don't have any good way to disable this or delete it. So for now, we just kind of have to put up with it, because the spotlight is not what's emitting the light. Even though it looks like it, the rectangle light is what is emitting light from this bar. And it averages all of these cells together and then uses that average number to put out its color of light. These are all of the so this is the head mesh, and that holds our static mesh X4 body, which I'm bringing up right now. So this is the static mesh body. And then what I did is I no longer set the material in the blueprint editor. I set it in the static mesh and then save it so that this static mesh is always linked to these materials. The lens first, the glass cover second, and the single pixel body material third. Additionally, all of the beams are there we go. All of the beam meshes are parented to the head mesh in addition to the rectangle light. I'm pretty sure I can raise this entire thing up a bit now, as it was sinking through the ground before, and my rotation on the head should still be the same. The rectangle light is also bound to the static mesh head, and this point light I cannot figure out how to not use. So I'm just going to set its intensity to 0 and then go to rendering, make it hidden in game and not visible. In the construction script, I told you there's this, which may or may not be able to be removed. I'm still getting to that. We create our beam array in the construction script now instead of the event script. And all this is adding all of these beams, all the beam meshes, in order to the beam array variable. After that, we use this beam array to iterate through all of the meshes, so that if you do want to hide the beam meshes, and if this is set to true, we go through and over 20 instances of each of the beam array or beam meshes, we set it to hidden and no visibility. If this is marked to false, which it is by default, then we unhide them, set hidden to false, and set visibility to true. Once this loop is completed, we can then go to our hide light logic. So if hide light is marked true, we can now execute that and hide our light, turn off its visibility, or unhide it and turn on its visibility. This is done in the construction script now. It was done in the event graph, but I figured to repeat this 20 times per DMX frame over however many lights you have was probably slowing down my performance. So I did this to optimize it a little bit. And then if hide light is set to true, or is set to false, then we can set the attenuation radius of our rectangle light simply by changing this variable, which is exposed. And then as soon as you change it, it will automatically refresh the construction script and set that proper attenuation radius. If we go into our event graph, which fires off our DMX commands, let me give you a walkthrough of this. In some of the previous examples under event begin play, I had set fixture patch. It looked something like, one second. think this one has it. No. No, that is the one. I haven't refactored the compressed version yet. But what that looked like is this. This is an old blueprint. Set fixture patch using DMX component as the target, and then fixture patch reference, which is a variable that gets set and then converted and used throughout the blueprint. We don't need to do that now because we're using a DMX Fixture Actor matrix as the parent class, and it just handles that all. This fires every time a frame is sent. That's why it's firing right now, because I do have DMX connection. And this fires every time a DMX frame or packet is received across all fixtures. So you could use this for setting changes that don't tie into the construction script as well, or that you want during runtime. These are the nodes that it's shipped with that I disconnected because they're not being used, but I don't want to delete them just in case I need to pull one of them later, and I don't want to forget what it is. I'm going to comment that. All right, and then this is all my scripting here. So we start by doing what I call gather the overall attribute values, which is attribute values that pertain to the entire fixture. So dimmer, zoom, and tilt. We then get our values that are for matrix cells. And I'll go over this all again. But we get all of these values for every cell, the red, green, blue, and white value that we're sending. We then, if we're using our light, we average all of our matrix cells together. And that fires on, if you're going through this script and re-engineering it, be sure you're paying attention to what type of pin you're using. Because for a lot of this script, I use the loop body, and it goes all the way through. And the difference is this will fire 20 times per DMX frame, so only use it when necessary because there's 20 cells. Or in this case, 20 beam arrays marking or indicating each cell. This pin, I'm talking about this pin here. This pin fires 20 times per DMX frame. This pin on the completed fires once per DMX frame. So this fires after these 20 are fired. And so what I do is I add all of the matrix colors together into one that says average matrix color. So if my color was red, this value by the time all 20 cells have fired would be 2000. And I think I could actually see that if I say, I'm not sure what fixture I have, so I'll just do 501 through 508. Highlight is on. Yep, so here we can see that the values are 20, 20, and 20 because we're on white. If I do set my color down, this is red, and then this is green. We set our average matrix color to that, and then as soon as it's done firing, we then one time divide our average matrix color by 20, or our cell count. Once we do that, then our completed pin that fires once continues to go down the line and make some adjustments as needed. And so I'll give you another overview before I go into a high-level overview. We first gather all of the data that we need, overall attribute values and per cell values, and then we start applying it to the things that we need. So first up is the body. We run it through a loop, and then we apply all of our parameters for each cell and the zoom. The zoom writing on our fire once pin, and each cell firing on the loop body pin. Next we have our beam mesh. The beam mesh pertains to all 20 of these beams here. And we apply basically the same color per pixel that we applied to the body. We also apply that to each cell. After we do that, this is the per cell pin. That kind of marks the end of all of what we're doing per instance. And then the only event pin we have left is on loop completion. And then our next attribute, we've done the body, we've done the beam meshes, and now we just need to do the light. And so the light fires once per DMX packet. And then we use our average. This is the only variable we use, and I'll explain why in a bit. We use our average matrix color to color the light. We don't use every single cell because that's entirely too expensive. And then we set some other light attributes like the source height, the relative rotation of the head based on the tilt, the barn door angle of the rectangle light, and then using a I'm going to go back to the start in a second. Well, I'll do it now. Using these, not those, these ease functions to kind of make an adjusted dimmer value based on our zoom. We then apply that dimmer value at the very end to the set intensity of the light. So let's go through that a little bit slower, kind of node for node. And so on fixture patch receive, you can see that if I move my green value down, you can't see that, but you can see that it's firing. So if you want to set the light to disabled, if you're not using it for whatever reason, but you don't want to delete it, you can turn this to true and it will ignore everything. Up first, we get our normalized attributes values. I already showed you that. That runs off our get fixture patch, so we no longer need to run this node to everything. We can simply just, well, we're still running a node to everything now that I think about it, but it's a little bit easier to get. So then we get our dimmer, zoom, and our tilt value for the entire fixture. And our zoom value is actually split off into these two ease functions. And what these do is they're basically like linear interpolates, but they're not linear. They use a easing function, so it kind of works like a curve. And I think this, these all have different curves. I kind of wish you could see the curve on here to visualize it a bit better. But the one we're using here is ease out. And what this does is it gets a lot close. It starts off, I think, gradually going from A. And then as it approaches the end, then it drastically quickly goes up towards 20. And then same with this one. And so both of these are pushed to our little bus here. I call this the bus because all of our data kind of travels down it. And we use this instead of storing stuff to variables and recalling it later. Reason I do this now is because I found out that storing everything to a variable and calling it later, while it's useful and easier to program with, and the code looks a lot cleaner, it's slower because it's storing things to variables and saving them as it goes. So we push these up to the bus. There is a one for the beam, which has to be a bit more drastic, and then one for the light, which is a bit more normal. And then we have our normal. What happened to my labels there? I swear I just had labels there. Ah, there we go. Found them. next is our getting per cell values. By per cell values, I mean we have 20 cells in the fixture, and the attributes per cell are as follows: red, green, blue, and white. Our white we add to this fixture. We add to the red, green, and blue channel, and then clamp them all 0 to 1. After that, we then make a vector out of these three. And remember that this is in a loop body that repeats 20 times. So when we hit our branch, if we're using our light and hide light is not checked, then we're going to set our average matrix color to our average matrix color plus the current color. And notice that our average matrix color gets zeroed out at before these 20 iterations occur. And then over the course of 20 iterations, they go all the way up to a maximum value of 20, as seen right there. Then after these 20 iterations occur, we then run down this completed pin, and the first thing we do is set this average matrix color to be the average matrix color divided by the cell count. And so that means that it gets reduced then and scaled back to values of 1. We cannot put this function after this pin, otherwise it as well will get fired 20 times, and even after the first frame, your first cell's color value will be reduced to almost nothing because it's being divided by 20. The data that we use here that we have to tie in is the DMX fixture patch, and that's used to get normalized matrix cell values. And then we have to use our dimmer value. Let's make a little note here that this is dimmer. And that dimmer value gets multiplied by the vector. And we do that so that you can turn your master intensity down, or you can turn your master intensity up and then your cells up. But if you turn your master intensity down to half, it's going to lower all of these color output by half. Once we figure out our cell values, we can then start applying these to the fixture, and we start with the body. So if do not color body is checked, then we just go down here, and with head mesh as our target, which is this piece, which contains the material here that contains all these parameters, and then also, where was I? And then also contains the lens material, which also has the X4 zoom scalar parameter. And the glass cover doesn't have any actual parameters. I don't know why I have these. I think actually at one point I did color the lens a little bit, but I just go without it now. So I might refactor this slightly, but it's probably not going to matter much compared to what's actually going on. I'll try it out. I'll see how it looks. If I do end up modifying this, all that's going to happen is I would like to set an overall color to this glass cover. Or I guess I could send in the average light color and then apply that to the glass cover. I'm not going to do per pixel on the glass cover though. That's too much detail for something very small. So after we, let's see, where were we? We're on the body. So after we decide whether or not we're coloring the body, if we are not, we just set these all to 0 so that the emissive light does not cause extra processing. If we are using our colored body, We set vector parameter value on materials with our head mesh as our target. And this is still coming out of our per pixel. This is still coming out of our per pixel loop. So this is going to fire 20 times per DMX frame. What we've done here is you can consider it, we export or use this array index, and we also use the beam that's being referenced, or that's up, so to speak. The beam that is in the current loop, we use that static mesh component. We use the beam kind of later down the road. But the array index, that is pushed in directly as the number says. So in some other files, I have sort of formatted the text of these. And I think I'm going to save on that processing. And instead, in the blueprint, just call these variables 0, 1, 2, 3. So that we're not adding and appending text 20 times per frame. We just pass in the color. In addition to the body, coming from our on loop completion pin, which this thing's last task was to just set the average matrix color. Now its task is to set the X4 zoom parameter, which lives in lens. And so keep in mind that when you use set scalar as set vector parameter value on materials, it addresses all of the materials in that object, in that mesh component. And so here on this node, it's talking to this element number 2, single pixel material. On this node, X4 zoom, it's probably still looking in this material for a parameter called X4 zoom. But this parameter exists in X4 lens under X4 zoom right there. That is about it for this section. We don't need to push anything out of this, push any data out of this. We then go to our beam mesh. And this is the last thing that our per pixel loop is going to achieve. So we merge these two together because regardless or not if we color the body, we still need to move on to this next task in case they want to leave the body dark but use the beam meshes, which is very possible. So if they're not hiding the beam mesh, then we set scalar parameter value on materials for the zoom. And the difference between this, these carry the same name. The difference is that this one is talking to the target is the body, this head mesh. And on this one, the target is each beam that is stored in the beam array. So it's talking to a different static mesh component here. And that parameter name is also X4 zoom. That material is right here. If you click on any one of these beams and go to beam X4 or material X4 beam master, here's where you can dissect this blueprint. And so our color parameter value is called X4 underscore color. And our zoom parameter value is called X4 underscore zoom. And quick note on the cone shape, I have this texture coordinate here, and the values are changed here. It's to 0.5 and then 0.03. The reason I did that is if you look at these, each one is pretty skinny. And if we zoom them out, 501 through 508, let's go to the zoom. If we zoom these out, you'll see they don't get a whole lot wider going that way. And I do this to save performance because as soon as these overlap, their performance really gets impacted. But from the side, they zoom out a lot more. And so the 0.03 you see is its UV tiling, or its scale going this way, you know, expanding the length of the fixture. We have a problem here. Okay, let me fix that real quick. But the Y or the X that you see is this direction. Let's fix that little error real quick. Don't know why it's doing that. Okay, that doesn't make much sense. Alright, well, I'm going to get that fixed and append that video to after the explanation is done, because it doesn't seem like it really changes things. Let's see what happens if we use our tilt. So it's just some weird thing where the base isn't quite sitting right. I can't explain why, but anyway, I'll address that at the end of this video, and you'll get to see why I was doing that. Go back to our event graph. We've set our X4 zoom parameter on this material. We've set our X4 zoom material on this beam material, X4 zoom parameter on the beam material. And then we also set our X4 color on the beam material. After that, we are done. I merged these two together anyway in case anything is needed. But after we perform those actions, we are all done with our per pixel firing. So we can still call this on the per pixel loop. I'm probably calling it like 7 different things, but hope y'all understand. And then we figure out what our on loop completion is doing, and that is moving to address our light. And our light is different because it doesn't require any per pixel values except what was received by the average matrix color for all the cell values. So we take this average matrix color and apply it to our rectangle light. And remember, this still responds to our master dimmer. So I actually don't know why these are not showing anything right now, given that the fixtures are turned on and are theoretically emitting light. But anyway, the average matrix color is pushed to the set light color, and then just know that you have to split these pins and then give it a alpha value of 1. After that, we use our zoom parameter and our tilt parameter, and zoom does a number of things here. So the raw zoom value, it lerps between 50 and 5, and that sets our source height for the fixture. Our source height is essentially how big this light is. So the rectangle light, its source height is this. So actually, as it gets skinnier, we kind of lower in this source height so that we can simulate the impression of it looking skinnier. After that, we use the tilt parameter, and we lerp between 100 degrees, linear lerp between negative 100 degrees and 100 degrees. And then we apply that on a set relative rotation to the head mesh, which is that wiggle thing I showed you earlier. This part. And then after that, we set our barn door angle on our light that's also based off of our zoom. And that just uses the variables max barn door angle and minimum barn door angle. And that is to give the simulation of zoom on the rectangle light. But what it doesn't account for is the brightness. So then we need to, that's where we use this adjusted intensity for the light, which I never went over this one, so I will. But we use this adjusted intensity that runs from the first ease function for the light and then apply that to the intensity so that as we approach narrow, the brightness goes up very quickly. And you need this ease function to provide that proper ratio. The adjusted intensity for beam, that goes to the X4 color parameter and gets multiplied by, so we have our incoming color per pixel. First it gets multiplied by the haze amount, which should be 0 to 1, but you can crank it up to be higher. And then that value gets multiplied by the adjusted intensity for the beam. And that is to account for zooming, so that as we zoom in, the beam and the light, but on separate eases, the beam and the light scale proportionately to the zoom. After we do that, that is the entire blueprint. So it's a lot of data, but overall what I've learned from doing this is that it's much faster and cheaper and better frame rate to push the values along directly instead of store them to variables. If I could get around storing this to a variable, I would. But so far I haven't figured out how, so it's going to be stored to a variable for now. I believe that's it. Let me figure out what's going on with this body here. It should be a pretty quick fix, so I'm just going to leave this recording and time-lapse it. Alright, well, I don't know if it was anything. Sometimes when I make updates to these fixtures, it bugs out, and simply by deleting it and bringing in a new one, it kind of fixes any issues. Let's take a look at the material blueprint for this, especially for the body. And we can find that on element 2. Now I refactored this a lot, so it's nice, one just big line. It was pretty messy, and so all it relies on is this material function that I created called set pixel position. And what that does is references a texture, it's kind of hard to see from here, which is just white, assuming the first pixel was lit. It takes that texture and takes a coordinate in, but then takes a scalar value, or a scalar value for the x coordinate that simply multiplies it by a defined number, a very specifically defined number that is able to spread that pixel. And in this case, in most of the textures, I went just one direction, just along the X, and then I started down here on the Y. This one I was newer, so I went diagonal. So it increments that small number, 0.026, is the amount 0 to 1 that it will move this cell over to reach the next cell position. I was able to simply do this because all of them are the same. And so all I need to do is pass in an x coordinate that says this is cell 1 or 2 or 3 all the way up to 20, and it will multiply it by these two numbers and then move this pixel exactly where it needs to be. This parameter input is, and by the way, quick note with these two values is how I discovered these values is by building, just like by duplicating this. I made two more coordinate ins, and then in the actual material I was able to promote those to variables. I can't do it here, but you would just click something and say promote to variable or promote to parameter. And so I was able to promote those to parameter and then move them around so that I can find the exact position. But as it turned out, I needed to get all 20 of these lined up to find the exact position. Like to get that number really dialed in. So after we adjust our position here, we then multiply it by the parameter color. And I believe this parameter color has to live outside the material function. I haven't found a way to get it back in or to get it inside here without creating 20 material functions, which kind of defeats the point of a material function. So the other thing that this has, so it finds this and then multiplies it by the parameter color. And then it takes in the previous, or what you could call the running texture of all 20 of these, and it just adds the result of this to that and then passes it on. And I did that so that I can daisy chain all of these without having to add them outside the blueprint. Aside from that, I have one UV texture that has all of the lenses, and then I have another just base color that goes to the base color, and the metallic value and a roughness value. That is the body. And so if this were doing a rainbow chase, then all of these parameters here would be rainbowing internally. You wouldn't see them rainbow in the actual node graph though. All right, well that wraps up the walkthrough of this fixture. I hope y'all got some value out of this. And yeah, this is a nice little fixture that I've perfected over the years. I want to make sure that if I add in my white value, that it responds correctly. And it looks like it does. So that's my white value at full. And then I can back it off just ever so slightly. And then I can go to like blue and then do the same thing, and it's a little more obvious. So that is it for now. I think the only thing I may have forgotten to touch on is that all of these static meshes under shared assets, all of these static meshes are now attached to the actual, or all the materials are now attached to the static mesh instead of a blank static mesh with blank materials, and then those being added into the in the blueprint. So anyway, thanks y'all for joining in. If you want to access this fixture, you could sign up for my basic tier on Patreon. Oh, and then one tip is if you're ever in editor mode and you want to see what they actually look like, hit G and you'll go into game mode. You could already be in game mode, and if you hit one of these, it'll bring it up. But if you hit G again, it'll put you right back in game mode. Thank y'all for joining in, and I will see you guys when I make more DMX fixtures.